Alright, these are our notes for section 6.6, and 6.6 is on vertex form. Alright, vertex form is the third form we've learned on how to express a quadratic equation. First we learned standard form. And for standard form, some of the things you have to remember are your axis of symmetry. Remember the formula for that is x equals negative b over 2a. Something you should remember. How to find the vertex. Those are things that we learned. And remember, your vertex is the AOS, and then the answer you get when you plug the axis of symmetry in. Those type of things are what you need to do for vertex form. Okay, and how to graph it. One other thing is you got to make a chart, and that's important. You will make a chart with 5 values in it, vertex in the middle, 2 above, 2 below the x value, the axis of symmetry, and that's how you graph it. You find those 5 values, plot those 5 points, and then connect them to make your parabola. Factored form was the second one we learned, and it is y equals parentheses x plus z1 stands for the first 0 or the first root times x plus z2, which is the second answer. Now they may be the same, that's called a double root, remember, but that's the form it looks like. And when you do this, you need to remember that the roots are x-intercepts. They are where they cross the x-axis. And we don't really find a vertex when we do that. We just plot our 2 x-intercepts, and then we sketch it whether it opens up or whether it opens down. We make it look nice. Okay? A little different than standard form. Less work than standard form. Now the third one we're going to look at is vertex form. And vertex form is different than those two. It's got a squared in it, but it also has parentheses. So it kind of combines both ideas. It's putting both forms together in one. Now, what's nice about vertex form is just by looking at it, you can tell what the vertex, what the axis of symmetry are, and whether it's going to open up and down. A tells you whether it opens up or down. And it's the same as it is in standard form. If A is positive, it's going to open up. If A is negative, it opens down. Okay, that'll be one of the things I ask you for, whether it opens up or down. Next thing, the vertex. The vertex is HK. Now notice H changed signs. That's important. It was negative in our formula. Y equals A times the quantity x minus h squared plus k. It was negative there, but it changes its sign when we put it in the vertex. Okay, that's important. H changes sign. Alright, but you can tell by looking what the vertex will be. The axis of symmetry is just as easy. It is x equals h, and again, h changes sign there also from what it is in our formula. Okay, so by looking, you can pull out those 3 things, which is what's nice about vertex form. We've got 3 examples here we're going to look at, and for each example it says give the axis of symmetry, the vertex, and state whether the parabola opens up or down. We're going to do them in that order. You can really do them in any order. It doesn't matter. They're all pretty easy, but we're going to find them in that order. So the first thing we're going to do let's make this example 1. Y equals negative 3 times x plus 5 squared plus 2. Okay, we're going to find the axis of symmetry. AOS. X equals, now remember it's h, but it's the opposite of h. H in this problem is 5, so we're going to make it negative 5. Okay, it has to change its sign. The vertex is HK, so h again has to change its sign, so it should be negative 5. And then k in this problem is 2. So our vertex is negative 5, positive 2. And make sure it's an ordered pair. They need to be put together. The last thing we're going to find is up or down. That's probably the easiest one of the bunch. Okay, we look at what A is, and A is negative in this case, so it opens down. Our parabola points down, like that. And that's all we need to do. That's the information we need to give. The axis of symmetry, the vertex, and whether it opens up or down. Then the next one is a little different. It is missing something. If you look at it, y equals parentheses x minus 2 squared, and then there's nothing at the end. There's really a 1 out in front here. Okay, it's not written, but A is a 1. So A is there. It's not what's missing. There is no K, though. If that's not there, it's really 0. Okay, it's really plus 0 in our problem. We don't have to add that. We're going to understand that it's there. So when we go through and we find our axis of symmetry, x equals, that's what h is, but it's the opposite of h. So here, x is going to be positive 2. Our vertex, h has to change its sign again, so it's positive 2 again, but there is no k, so it's 0. It's 2, 0. And then it's going to open up or down. When we look at a was a positive 1, so it's going to open up. Our parabola would look like that. And that's what we do for that one. If there is no k, remember it is 0. The last one here, example 3, we've got y equals x squared minus 6. This one's missing something also. Notice there are no parentheses. If there's no parentheses, that means it's missing h. Okay, and just like if it's missing k, h is going to be 0. So for our axis of symmetry, x equals 0. You don't have to change the sign of 0 because 0 is 0 whether it's positive or negative. Let's find our vertex now. H is still going to be 0. And then k is negative 6. Make sure you take the sign with that. It's important that you take the sign with it. Okay, since it's not in parentheses, that k is all of that number at the end, so negative 6. And then the last thing we need to figure out is whether it opens up or down. A will still be in the same place that's in front of the x squared, and again, it's not written, so it's understood to be 1. 1 is positive, so it's going to open up. And that's what our third example looks like. X equals 0, 0, negative 6, and it opens. All right, the next thing we're going to look at is how to graph in vertex form, which is really easy. The first thing you need to do is to determine all of that stuff we did on those other examples. The AOS, the vertex, and up or down. Okay, that's what I want you to do first. Figure out those 3 things. And then you're going to plot those. So step 2 would be to plot. You're only going to plot your AOS and your vertex. You can't really plot up and down. Okay, but AOS and your vertex, you're going to put those in your graph. And then the third thing is to make a chart. Okay, similar to the chart we do in standard form, only this time we only need 3 values instead of 5. Okay, when we make our chart, we want the vertex in the middle, and then one larger than our x and one smaller than our x. So that's why we need 3. And if we remember, if we go the same distance of way, if we go one larger than it and we go one smaller, those values should be the same because it needs to be symmetrical. So keep that in mind. If you're going the same distance away from your x value, from your axis of symmetry, they should be the same value. Okay, let's do our example here. Our example is y equals x minus 3 squared plus 2. So the first thing we need to do is figure out the AOS, the vertex, and whether it opens up or down. AOS, x equals, got to change our sign from the h, so it's going to be positive 3 because it's negative in our problem. Our vertex, h is going to be positive 3 again because it needs to change, and then 2 because that's what our k is. And a is out in front. It's 1 because it's not written, so it's positive. It's going to open up. So let's plot that. X equals 3. Our axis of symmetry is going to be a dashed line, a dashed vertical line that goes through whatever value it is, so 3. And then our vertex is 3, 2. So we go to 3 and we go up 2 and we're going to put a point. And we do know that's going to open up. If it opens up, that's going to be a minimum value for our vertex. Remember back to 6.1, the first section we talked about. If our parabola opens up, it's got a low point, which means it's going to have a minimum value. Now the next thing we need to do, we plotted them already, so we're going to make a chart. We've got to make an XY chart. X, Y, middle value needs to be our vertex, so 3, 2, and we need to choose a number smaller. I'm going to choose 2. 2 is smaller than 3. And then a number larger, 4. 4 is larger than 3, and both of those are the same distance away from our axis of symmetry. It's 1 larger, 1 unit larger, 1 unit smaller. So we're going to plug 2 into our problem. It would be, parentheses, 2 minus 3 squared plus 2. Well, 2 minus 3 is negative 1. We're going to square that, plus 2. Negative 1 squared is positive 1, plus 2 is 3. So there's our value for 2. Let's check and see if 4 is going to be the same, because like I said before, it's got to be symmetrical. So whatever it is on the left, the lower part of it should be the same on the upper part when we count higher. So 4 minus 3 squared plus 2. 4 minus 3 is 1 squared plus 2. 1 squared is 1. plus 2, we did get 3, which is good. We want them to be the same. So now we'll plot those. 2, 3, 4, 3, and then we will sketch our parabola. And that's how we graph in vertex form. Pretty easy. A little easier than standard form because we don't have to find as much stuff and remember a formula. Now the next thing we're going to look at, last thing here, is if we're given points, how do we write those in vertex form? Alright, so if we're given points, the first thing we need to do is plug in h, k, x, and y. Right? They'll give you 2 points. They'll give you the vertex, and remember your vertex is hk, and they'll just give you a point, and your point is going to be x and y. So you plug those values into the equation, into y equals a times x minus h squared plus k. You plug all that in. Step 2 is you're going to solve for a. You want to figure out what a is, because it'll be the only variable that doesn't have a value for. So you'll solve for a. And then step 3, you're going to rewrite, but you're going to leave x and y variables. That's what makes it an equation, having an x and a y in there. So you'll plug in your vertex and you'll plug in a. Those will be what you have values for. Let's look at our example. We've got one example like this. Our vertex is 1, 2, and our point is 3, 4. Remember, our vertex is going to be hk. Our point is going to be xy. So let's write down vertex form plus k, and we're going to plug in those values. Well, y is 4, a is a variable, x is 3 minus 1 squared plus 2, and we're going to simplify that. 4 equals a, 3 minus 1 is really 2, but we have to square it, so it's going to be 4 plus 2. Subtract 2 from both sides, so 2 equals 4a. Divide by 4. A is 1/2. Okay? And that's what we're going to find. That's step 2. Find what a is. Now we're going to plug it back in for step 3. I'm going to rewrite vertex form just so we can see where our numbers are going. And I rewrote it wrong. X minus h squared plus k. We're going to plug in for a, which is 1/2. X and y stay variables. Minus vertex is 1 here. And then k is 2. So there would be our equation. Now one thing I do want to warn you of is if say your vertex, say our vertex was -1, -2. I'm going to write watch out for this. Okay, if this were my h and k, if I plug that in, it would be x minus minus 1. That's really positive, so pay attention to that. It's really x plus 1. Two negatives together, remember, they make a positive. So watch out for that. I do want to point out one thing, how to go from vertex form to standard form. I'm going to rewrite our problem here. X minus 1 squared plus 2. Now, if I want to take this is in vertex form, take this to standard form, all I need to do is simplify it. Okay, and the first thing we should do is FOIL. Now we're going to FOIL because of our squared. And I'm going to rewrite it so it's y equals 1/2 x minus 1 times x minus 1. Remember, it goes to both because it's squared plus 2, and we would FOIL that. So it's x squared plus 1, minus 1x minus 1x plus 1. And that's all in parentheses with the 1/2. And then plus 2. We can combine like terms, so 1/2 x squared minus 2x plus 1, but that plus 2 still outside. Distribute our 1/2 through, and this is where people usually make mistakes. They'll try to add that 2 in before distributing. You got to remember your order of operations. Okay, parentheses first, which is what we did, and then the exponents. Those kind of go together in this problem, but we are going to multiply before we add or subtract. So we want to do this first. So we would get 1/2 x squared. 1/2 times -2 is really -1x. And then 1/2 times 1 is going to be plus 1/2. Now we can have plus 2 in there because we've gotten rid of the parentheses at this point. So these two will combine and we get y equals 1/2 x squared minus x. 1/2 plus 2, that's really 2.5. But we want to make it an improper fraction. So we would do 2 times 2, the denominator times the whole number, plus the numerator. 2 times 2 is 4, plus 1 is 5, so we would say plus 5 over 2. And that would be our answer in standard form. Okay, and that is how you switch between vertex and standard form. Those are your notes on section 6.6 on vertex form. Make sure you bring any questions you have to class tomorrow. And again, those are your notes on 6.6.